Hi. So this is my presentation for the combined cycle power plant MN analysis. I prepared a small document in order to give this presentation seamlessly. This project analyzes a combined cycle power plant dataset with 9,568 hourly readings. And the aim of this exercise was to predict the electrical energy output, which was our target variable, PE, as provided in the dataset. So the features are, as mentioned, 8 is ambient temperature, and this is the range of 1.81 to 37.11 degrees Celsius. V is your exhaust vacuum, and this is the range, ambient pressure, range, and the relative humidity. So these are the four features in this particular exercise, and our target variable is PE, net electrical power output, and the range for which is 420 to 495 megawatts. So this problem is basically a regression problem as it involves predicting a continuous numerical value, and the evolution metric which I will pick for this particular problem would be MEE, mean absolute error, and root mean square error. These will be the two metrics I think which will be able to evaluate this model the best way, as it is a regression problem. Data split which I have taken between the test set and the validation set, and then the final is 80 10 10. So the total samples I mentioned. So after I did the exercise on, so I basically trained that my two features on Google's AutoML on Vertex AI, and I have done basically prepared train two models. In my first model, I have picked all the four labels, and in my second model, I have picked the three most prominent features. And these features, if I may, so as you can see, for temperature, there is a strong correlation, but it is a negative correlation of minus 0.9, whereas for exhaust vacuum, it is minus 0.8. 7, again a strong negative correlation. For ambient pressure, it is a moderate positive correlation, and for relative humidity, there is a moderate positive correlation. But if you see all these four factors, the least impact on the electrical output is from relative humidity. So these are the two models which I have created. So some screenshots of while I was trying to create the model on AutoML. So selection of the features and aligning all these things I have done. So this is the comparison between the two models, as you can see. So where I when I selected three features, the most prominent features, my MAE is 2.539 versus when I select all the four features, it is 2.62. And if I see RMSE, root mean square error, it is lesser for when I select the three features versus when I use all the four features. So this is how it is, and basis the MAE and RMSE values, there's not a big gap, but considering lower meaning the better, we will use the model one, the power plant three features model, and this will be our best model for this particular exercise. These are the final numbers of the test set. This is the coefficient of determination, which was coming out to be 0.962. Uh, and now let me give you a live prediction demo. So here are both the models which we have trained. This is on AutoML. Let me open this. So this is the final model which we have selected. I have deployed it to an endpoint so that we'll be able to test. So here are the values. Let's say the ambient temperature is 28 degrees Celsius. The exhaust vacuum is, let's say, 62, and let's say the ambient pressure is, let's say, it is 983, and let's say the relative humidity is 64. Predict. It should be able to predict a value basis this training. So it has predicted 421 megawatts as the value if these are your input parameters or these are the features values of these features. And so basically, the four main points of the presentation, the modeling approach was that it is a regression problem. In first model, I used all the four environmental features. I selected the appropriate algorithms to train my model, but that was more or less done by AutoML itself, and compared two different models and used validation set approach. And my model evaluation for my metrics was mean absolute error and root mean square error, and I calculated that on test set also, achieved good amount of accuracy. And I think this is my presentation. Thank you.